Example 1. In the grounds of a castle, it is planned to construct a herb garden which is to be rectangular in shape. It's intended to be surrounded by a path and divided into squares by tracks. Each square is to be 1 unit long, where 1 unit is 20 metres. So for example, this would represent 1 unit, which is 20 metres in real life. The diagram above shows the plan of a herb garden, which is 4 units by 2 units. We want to determine a formula for P, the length of the path, and for T, the length of the tracks. For a herb garden of dimensions m by n units, where m and n are elements of the natural number set, so positive whole numbers. So part 1, conduct an initial exploration, i.e. that is, examine the value of t for some initial values of m and n. So if we start off with n is equal to 1, then there are no horizontal tracks in our diagram. Likewise, if m is equal to 1, then there are no vertical tracks in our diagram. For example, consider a 4 by 1 garden and a 1 by 4 garden. So for example here, if n is equal to 1, then we actually don't have any horizontal tracks in our diagram, because this would then be the perimeter. So if n is equal to 1, then m will be equal to 4. 1, 2, 3, 4. If it was the other way around, if m was equal to 1, then there'd be no vertical tracks. So we would have this to be the perimeter of our garden. So if m was equal to 1, we would end up having 1, 2, 3, 4 units for n. So the 4 by 1 garden has m minus 1, which is equal to 4 minus 1, which gives us 3 vertical tracks, each of a length of n equals 1 unit. So the 3 vertical tracks can be seen here, 1, 2, 3. The 1 by 4 garden has n minus 1, which equals to 4 minus 1, which also equals 3 horizontal tracks. Each length of m equals 1 unit. So 1, 2, 3. 3 horizontal tracks. It's a very good idea to draw these sketches out so you can really see what's going on. So if n is equal to 1, then m is going to be 4. 1, 2, 3, 4. And we would have 3 vertical tracks. If m is equal to 1, then n will be equal to 4. 1, 2, 3, 4. And we would have 3 horizontal tracks. Obtain a formula for P and for T for a garden of dimensions m by n units. So P being the perimeter of the entire garden, or the path around the garden, the perimeter of the entire rectangle, and T being the tracks. Consider a garden of m by n units, so m by n units. Let P be the length of the path, so the path around the edge, so the perimeter, and T be the length of the tracks. P, the perimeter, is going to be P equals 2m plus 2n. So if this is our rectangle, and if this length is m, then this length is m. And if this length is n, then this length is n. And m plus m gives us 2m, and n plus n gives us 2n. So n plus m plus n plus m will give us the perimeter of our rectangle. So P equals 2m plus 2n. Okay, so T is the sum of the vertical tracks and the horizontal tracks. The length of the vertical tracks is going to be m minus 1 times n. M by n is mn, minus 1 by n is minus n. And the length of the horizontal tracks is n minus 1 times m. N by m is mn, and minus 1 by m is minus m. So if we just have a look at our answer from part 1, it'll help us out with figuring out where these came from. So this was the sketch that we drew in part 1, and we noticed that we have m being a length of 4 and n being a height of 1, and we have 3 vertical tracks in between. So the length of all the vertical tracks is going to be m minus 1. So in this case this was 4, and 4 minus 1 makes 3 vertical tracks. So it's m minus 1 times n. So whatever we sub in for our m, we're going to take 1 away and multiply it by whatever we have for our n. So m minus 1 times n, it's going to give us mn minus n. So now let's have a look at the horizontal tracks. So our horizontal tracks formula is going to be n minus 1 times m. So in this case our n was 4, and 4 minus 1 makes 3 horizontal tracks, and that would be multiplied by whatever our m was. So no matter what we have n for, we're going to minus 1 and then multiply it by whatever we have for m. So n minus 1 times m is going to give us mn minus m. Now we know that to figure out a formula for all of the tracks, we need to add together the vertical tracks to the horizontal tracks. So it's going to be both of these formulas added together. So it's going to be mn plus mn, which will be 2mn, and minus n minus m. So our actual formula for the tracks, the length of the tracks, is going to be 2mn minus m minus n. Okay, part 3. If the length of the path is to be equal to the length of the tracks, show that n is equal to 3m over 2m minus 3. So they're equal to each other. So we're going to take our formula for p, the perimeter, 2m plus n, and we're going to equal it to t, the formula for the length of the tracks, 2mn minus m minus n. So we're going to have p is equal to t, so 2m plus 2n is equal to 2mn minus m minus n. And then we just have to solve for n. We have to get the n on its own. So what I want to do is gather all my like terms together. I have 2m on the left, and I have minus m on the right. And if I bring this minus m over the equal sign, it becomes plus m. And 2m plus m will give me 3m. So I brought the minus m over the left of the equal sign. Now I also have 2n on the left of the equal sign, and I have minus n on the right of the equal sign. So I'm going to bring this minus n over the equal sign, and it becomes plus n, and 2n plus n give me 3n. So again, I brought this minus over the equal sign, and 2n plus n make me 3n. And this is still equal to 2mn. So now what I want to do is get all my n terms together. So I can keep the 3m where it is, and I'm going to bring the 3n over the other side. So that 3n is going to become minus 3n. So now I have anything containing an n on the right of my equal sign, and anything without an n on the left of my equal sign. And it doesn't matter which way you have it around. So what I'm going to do is I'm going to factorize both of these terms, taking out the n as the highest common factor. And 2n into 2mn, the n's will cancel and leave you with the 2m. The 2m comes down here. And n into minus 3n, the n's will cancel, leaving you with minus 3, and that comes down here. And that's equal to 3m. So really we swapped these around, and then we factorized. Remember, I'm trying to solve for n, I'm trying to get the n on its own. And since the n is stuck onto 2m minus 3 with brackets around it, that means multiply, and the opposite of multiply is divide. So I'm going to have to divide by 2m minus 3 to get the n on its own, which I do. But I must divide the right hand side also by 2m minus 3. So I end up with 3m over 2m minus 3. And that is exactly what I wanted. If the maximum area available for the herb garden is 200 meters by 200 meters, what are the possible dimensions of the garden for which the length of the path is equal to the length of the tracks. So what dimensions? That basically means what are my m and n values. So what's my width and my length of my garden, but we're going to call them m and n because that's what we decided to call them at the start. So if the maximum size available is 200 meters by 200 meters, then the maximum size is 10 units by 10 units, because we were told at the start that 1 unit is equal to 20 meters. And 200 meters divided by 20 meters leaves us with 10 units. So it's going to be 10 units by 10 units. That's going to be the maximum size available. So we're interested in dimensions of the garden for which the length of the path is equal to the length of the tracks. So where P, the perimeter of the path, is the same as T, the length of the tracks. So P is the same for an m by n and n by m garden. And we also need to remember that m and n are natural numbers, so positive whole numbers, and there are at least 2. And the reason why there are at least 2 is because if we were to do m minus 1, let's say we let m be 1, then m minus 1 would be 1 minus 1, which would be 0. And that doesn't make sense. We can't have a length of 0. So our m and n must be at least 2. So the formula that we were given in part 3 was n equals 3m over 2m minus 3. So we know we can't substitute in 1, but we can start off by subbing in 2. So if I let m equal to be 2, I'm going to have 3 multiplied by 2 in my numerator, divided by 2 multiplied by 2 minus 3. 3 by 2 is 6, 2 by 2 is 4, minus 3 is 1, and 6 over 1 is just 6. So if I have a 2 by 6 garden, then my path and my tracks will be equal to each other. If I sub in 3, I'll have 3 by 3 divided by 2 by 3 minus 3, which will give me 3. So if I have a 3 by 3 garden, then the sum of my perimeter and the sum of my tracks will also be equal. And if I sub in 6, I'll have a 3 by 6 divided by 2 by 6 minus 3, which will give me 2. So if I have a 6 by 2 garden, again, the sum of my perimeter will be equal to the sum of my tracks. And there are no other integer values of m that will give n as a natural number. So any other integer values that you would try for m, you would end up getting a decimal. So that's not going to work out. So the dimensions of the garden for which the length of the path is equal to the length of the tracks will be a 2 by 6 garden, 2 units by 6 units, a 3 by 3 garden, 3 units by 3 units, and a 6 by 2 garden, 6 units by 2 units. Now, they didn't ask us to actually find the real length of the dimensions of the garden, but if they did, all you would have to do is multiply the m and the n values by 20. So 2 units by 20 meters would be 40 meters, and 6 units by 20 meters would be 120 meters.